Hello, this is Mr. Barr, and we're going to do transformations, rotations today. Rotations. Goal, I can manipulate shapes using transformations. Why? Computer graphics are just transformations. I want to understand how software works. Computers use math. Computers use math to rotate images. Today you're going to learn the logic that computers use at a very basic level to rotate an image. So here's an image that was rotated 90 degrees clockwise. First off, in our notes, we need to know what clockwise and counterclockwise are. So let's get started with this. Into your notes, start with your name, and the title today is Rotations. So name, transformations. These are all transformations. More specifically, today we're doing rotations. When something is going like this, that's clockwise. When it's going the other direction, that's counterclockwise. And we also need to know some degrees here. So when something just goes that far, that's 90 degrees. That far is 180 degrees. This is 270. And 360. So we're going to be rotating things today, like 90, 180, 270. A 360 rotation isn't really done because you just end up with the exact same image again. Clockwise, counterclockwise, 90, 180s, 270s, 360s. The key to rotations is having two pieces of paper. You're going to draw the shape twice, and then you're going to rotate one of the pieces of paper, and then you're going to copy it onto the original sheet. So we are going to rotate this guy right here, and it's going to start with graph paper. So let me get some graph paper. There's some graph paper. I'm going to take this one right here and fold it to make 4 boxes. And I'm going to draw a coordinate system on it. And on that, I'm going to plot the point at 4, 2. 4, 2. 1, 2, 3, 4, 1, 2. And what are we going to do with that point? We are going to rotate that 90 degrees clockwise. Now I told you I'd be using 2 pieces of paper. So let me get another piece of paper here. So here's the second piece of paper. And on this one, I'm going to keep it little like this. I just need 1 square of it. I'm going to draw another coordinate system. And I'm going to very specifically label this as up. And I'm going to use a pencil so I can reuse this over and over again. Hopefully I have a pencil that has... Oh, come on, have a pencil, Mr. Barr. Okay, I have a pencil. And on this, I'm going to put the exact same point. So I'm going to have another point at 4, 2. All right. So notice I have the exact same thing twice. I am now going to rotate this 90 degrees clockwise. Here we go, 90 degrees clockwise. And now my point is right here. Where is it at? It's over 2 and down 1, 2, 3, 4. Over 2, 1, 2, 3, 4. It's right there. This one I can use marker on. And there is my A prime. So what I do is I draw it twice. I draw it once on my final page, and I draw it once on this temporary one. Then I take my temporary one and I rotate it, and then I take this point right off of that and put it onto the original one. Let's try another one. There's the rotation. So get a coordinate system ready to go. And let's see, this is at 4, 3. 1, 2, 3, 4. There's B. And -2, 5. And there's A. So here's the original segment. And what are we going to do with that segment? We are going to rotate it 180 degrees. And it doesn't matter if we go clockwise or counterclockwise. It's going to end up in the same location either way. So what I'm going to do is I'm going to take my little piece of paper here. And since I was working in pencil, I can erase that last point, which is nice. I can just reuse this paper. And I'm going to plot the exact same segment on this paper. So 4, 3. And -2, 5. And I'm even going to label it this time. I'm going to label it as B. This is my B. And this is my A. And I'm intentionally trying to be kind of faint with it so I can erase it later. Now I'm going to take my little piece of paper. I'm going to rotate it 180 degrees. Doesn't matter which direction. And this is what I end up with. Or if I went the other way, that's what I end up with. So this is what it should look like after the rotation. So now I'm going to take each of those 2 points and just put them over here in the exact same locations. So 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, and that's B prime. And A is at 1, 2, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5 right here. There's A prime. There it is, after the rotation. And everything that I put over here, I can just erase, and I can use this little piece of paper for the next one too. Let's do another one. This time we're going to do it with a triangle. Okay. So you're going to need another coordinate system. You can just flip your page over. I, on the other hand, I'm going to have to draw a new one. Or get a new piece of paper. So let's start with a coordinate system, and we'll draw the original triangle. So there's my coordinate system, and my triangle is at -2, 3. -2, 3. There's my C. Looks like -6, 2. There's my A. And -5, 5. And there's my B. So here's my triangle. And what are we going to do with that triangle? We are going to do 90 degrees counterclockwise. I get my little piece of paper. There's my little piece of paper. And I plot the exact same triangle. So this was at -6, 2, 1, 2, 3, 4, 5, 6, 2. And what's that one at? -2, 3. And -5, 5. So that's A, C, B. Now I'm ready for my rotation. Rotate 90 degrees counterclockwise. Now I'm going to take each of these points and I'm going to put them right over here. Hopefully it fits. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, and 6. C prime, B prime, A prime. There's my rotated triangle. So I draw it on the original paper, I draw it on the little paper, I rotate the little paper, and then I take the shape off of the little paper and put it onto the original paper. That's our method for this. There it is. Now notice that when I start changing the shape of it, or rotating or moving around or something, it doesn't actually change its size. So I look at this triangle right here, and I can use Pythagorean theorem to find AB. So let's find AB. This is 1, 2, 3, this is 4. This is 1, 2, 3, 4, 5, 6, 7, 8. So this is 16 plus 64, which is, what's that, 70, 80? And the square root of 80 is just a, like, what's that going to be, 8.9? 8.9. So this length right here is 8.9. And if I start rotating this thing around, then what's it going to be? 8.9. And if I translate it, what's it going to be? 8.9. And if I reflect it, what's it going to be? 8.9. It's going to be 8.9 no matter what. All right. It's going to be 8.9. All right. I feel like, so this is practice stuff that you would do at this point. Oh, rotating around a point A. It's a little bit different. So if I took this shape right here and rotated around point A, how would that work? Let's try it. Let's use this little piece of paper. Around point A. So right now I have -2, 1. And I have 2, -4. So I have this line segment right here. And what I'm actually going to do is I'm like going to try to pin it right there and rotate it like that. And notice that this is still that. So this, okay, so ready? This point isn't actually moving. I don't have a good way to explain this, do I? So where is this point? This point is at -2, 1. Ready? Now I rotate it. What's it? 90 degrees clockwise. And where is this point? Well, this point is still at -2, 1. Right? So this point is at -2, 1. So really what's happening is the coordinate system is moving. This is my new segment right here, using this coordinate system. You know what? I'm not explaining this too well. Hopefully you're going to be in class when we do this one. You're not going to really see this too much. So that's why it's just kind of a little bit of an afterthought on this one. Okay. How did we do? Wow. I'm wrong on that, aren't I? Clockwise? What did I mess up? Did I do counterclockwise? I went counterclockwise, didn't I? I went counterclockwise. All right, hey, that's it for today. Thank you for watching. Oh, here's another one, rotated around point B. So I take it here, and I'm rotating it around point B, as opposed to around the origin. All right, hey, that's it. Thanks for watching. Stop.